Okay, so this is chapter 3 for CSC 155, talking about cell references, named ranges, and functions. All right, some of the stuff we're going to talk about, things we cover in this, different types of cell references, the concept of named ranges, the ability to create structure functions within Excel, as well as some of the other functions that are out there: math, statisticals, date and time, text, lookup, financial, logical, troubleshoot, and logical functions and troubleshoot functions, and then also the ability to use conditional aggregate functions and conditional math functions. All right, so a fair amount of stuff in here. So to start off with, we're talking about cell references. All right, so remember that a cell in Excel, every cell in Excel, an Excel worksheet has its own unique address made up of the column and the row. All right, so A5 would be column A, row 5. And the way Excel works is you can either you can either use a direct value, you can put a value in a formula, or you can put a cell address. And when you put a cell address in the formula, what it will do is it will read that as take the contents of that and do something with it. All right. So by default, Excel uses something we call relative cell referencing. All right. So A5 plus B4, relative. It will work with the cells relative, its relative location one to the other. All right. So what happens is when we do a copy, if we do a copy and fill of a formula, what it will do is it will automatically take a look at what's in the formula and then adjust it as we drag and as we do the fill exercise, as we copy it and move it across. It will take a look at it and will adjust the address. All right. So the idea is you can write one formula, in one cell, and then copy it, pull it down, and it will align itself, based upon the relative cells that are around it. So that's hence the name relative cell addressing or referencing. An absolute cell reference means that we lock it to a cell. So we lock a cell to an absolute address. All right. So the way we do that is, we look at the cell. If you look at the cell address, there's two parts to it. One is the column address, the other one is the row address. If we put a $ in front of the column address and a $ in front of the row address, that then becomes an absolute address, so that it will always use that address. So if I do a copy of that formula and I do if I drag it, create a whole series of formulas out of it, that address will always stay the same. So this is used in situations where you have one cell that you always have a fixed value in, and you always want to reference that cell. All right. Mixed cell referencing is where you kind of combine these two together. So what you have is a combination. You can either lock the row or you can lock the column. All right. So and you have a choice of either way. So if you do $A, what that means is the column is absolute. All right, and the row the reference to the row is relative, and vice versa. If you do $5, we'll see as our example here, the cell reference for the column is relative, the cell reference to the row is absolute. Anyway, so just some examples of some pictorial examples of how this looks. All right, so we'll take an original formula. When you copy it by default, Excel will use its relative locations to adjust the formula as it copies it from cell to cell. All right? Unless, of course, it is overridden by either an absolute or either the absolute cell reference or a mixed cell reference. We'll override that. All right. So here's an example here of an absolute address. So when I copy this formula here, the $, $1 will stay intact, however many times I copy that formula. All right. So as we say here, in this case, if I put a dollar sign in front of the column, the F will never change, but the row, on the vertical, so horizontally it won't change, vertically it will change. Another concept we have in Excel is what we call the name range. So a name range is, it's really just a name we can assign to a group of cells. And then we can reference that name in a function or a formula. All right, so the idea is, by default, the way we reference everything in Excel is through the cell addresses. So we can create a formula. Of our formulas will have the cell address in it. We can, though, create a, and what you can do within that, you can create part of what you can do in the formula. You can put a range of, it's not just simply as an individual cell address. You can put a range of cells in there. All right, so that would read something like, A:1 to, or A1 colon A8, which the first 8 rows, or the first, be the first 8 rows in the A column. All right. But what you can also do, though, is you can actually give that a name. So rather than have to use spelling it out as a formula, you can assign a name and then be able to use that name in functions, which makes it easier to read and remember and be able to work with. So and what it does is when you do that, it creates an absolute reference. All right. So what it'll do is it will lock that range of cells that we give a name to. We'll also lock it in as a named as an absolute reference. All right. So kind of an example here, and what you see is with the name ranges. If I create a named range, all right, I will see it up here in the name box. All right, so the name box is up here in our. If we look at our, up at the top, which tells us what cell we're on. If I have a named range and I select that range, it will show me that name in the range. In addition, we also can get to it. There's a couple different ways we can get to it here. So it looks a little bit different between Excel for Windows and Excel for Mac. So if you're on a Mac, you'll see a little bit of a different look. But where this resides at is going to be under the Formula tab on the ribbon. All right, so if we look at, we start off with File, Home, Insert, Draw as we go through. You have the 1, 2, 3, 4, 5. The 6th one in is Formulas. All right, and we'll look more at formulas in a little bit. But the Name Manager, there's a name function that lets us create names, define what the name range is, what the name, and be able to create them and delete them, all right, of what's out there. So the idea is really, you're creating a simplified structure in Excel, that we can, giving it as a referenceable name that is easy to work with, that is also usable in formulas. All right, so these are, like, as we say here, here's our, a bunch of named, as we see here, a bunch of named ranges. All right, and, we have it's just that this can be done under the formula bar. It can actually be done also on the, it can also be done, over in the name box. So there's a couple different ways. Once again, like a lot of things in Excel, a couple different ways to do this. So let's talk. So that's a couple ways to create some different kinds of structures inside of Excel. So let's look at what we call functions. All right. So we talked about functions a little bit in Chapter 2, but we're going to look at more. We're going to look at them more in depth. As we said, there's over 400 functions in Excel. So, obviously there's, and they've been around a while. So this is another one of those technologies that's had an opportunity to mature and develop over the years. So there's the formula capabilities of Excel are pretty are pretty significant. All right. So kind of from our starting point here, what is an Excel, a formula, or a function in Excel? It's a formula that's already built into Excel that we can call. So it's pre-written code. It comes with. So, for example, if you need to do a present value calculation on something, all right, you could go out and you can break your textbook and figure out what that would be and create that formula, or you can go and call the PV function, give it a couple of parameters, and it will give you a result. All right, so it's you could do a lot of the stuff that are provided in functions yourself, but since it's already there and it works, why would you want to do that? All right, so they can be either simple or complex. They can use arguments. So what arguments are the parameters. All right, so there's a couple different terms you'll hear sometimes. You'll hear arguments. You'll hear parameters. It's what you feed the function when you call it in order to execute on. All right. So the structure of this is all formulas begin with an equal sign. Right. So it is a formula. All right. So the first thing we'll enter an equal sign. Then we'll have the function name, followed by a set of parentheses. Begin opening and ending parentheses after the function name. And then if we're going to pass any arguments or parameters to the function, we string them out. We will add them following. And each function will have its own layout of what its parameters, what it will take, whether it can default, whether you can add stuff. And each one of those each one of the functions and the parameter structure for each of those functions is documented. All right, so you can go back and take a look at the details of each one has its own story. So it's the main thing around from the structure perspective, it's an equal sign, the function name, and then a set of parens, and then the parameter or the argument that we pass to that function depends on that function. All right. You always have to put a parentheses at the end, even if you don't submit parameters. All right. So by your function, by default, will always have a parameters at the end. If you don't put the parentheses at the end of the function, you'll get an error. All right. So we'll take an example, like some of the things we looked at. An average. With giving a parameter range of a range of cells. All right. So the way you would read that would be, take this range of cells. All right, and generate calculate the average of those, and then put those into whatever the cell formula is in. And you can do other things like rounding and things like that. But so a couple different types. The different types we have: mathematical functions. Those are numerical manipulations. Your plus, minus, multiply, divide. Generate absolute values. We have a function where we can feed it a range of parameters, and what it will come back with is it will generate an absolute value. You can also do rounding. Right? So you can have all sorts of different ways of fine-tuning what you want the math function, how you're looking to execute the math function. Right, so rounding is statistical functions. We talked a little bit about Chapter 2. So average, maximum, minimum, median, counting functions. Date and time. So date and time remember what we talked about within Excel. There's three. There's your text data. You've got numeric data, and then you have date and time. Right? Date and time are functions that are specifically designed to return or process date and time. Right? So A couple examples of them out there. So today, we'll return the current date. If I enter now, if I use the now function, that would return the current date and time. So the way I would put that in there, if I would enter into a cell, equal now, left paren, right paren, or equal today, left paren, right paren. A date diff function actually has been around a long time. So actually, it goes back to the days of Lotus. But what a date diff function will do is will return the differences in some value between two dates. So say, for example, you want to calculate the number of days between January 15th and May 30th. What you would do is you would put January 15th as the first parameter, May 15th as the second parameter. It would be, I think the format is 2020. It's year, month, day. If you look at the documentation, it'll give you an example of it. It'd be like 2020 slash 1/15 was the first parameter. It would be 2025 15 for the second parameter, and then you would put what you want the calculation to be. Do you want it to be in months? Do you want it to be in days? So if you put like a D in quotes, capital D in quotes at the end of as the third parameter to date diff, it will come back and will tell you the number of days that are between any two dates, right? Which is actually a pretty useful thing. A lot of times you'll want to, you'll be doing calculations and trying to do estimations and trying to figure out like timings and ranges of when things are supposed to go. Knowing the number of days is a pretty important piece of information that can be generated very simply using date diff. So that's a date function. Text functions, we can work with basically text data. So I can manage, manipulate, format text data. I can change the appearance of it. I can change it to all caps. I can change it to all lowercase. I can remove unwanted or erroneous data. I can shrink it. I can take all of the characters. I can take all the spaces out of it. I can strip off extraneous characters that I don't want. Those are all functions. Those are all separate functions that let us do stuff with text data. All right. So there's a set of functions associated with each of the data types in Excel. We have things like, for example, lookup and reference functions. So we can do simple matches, complex tasks. We can do these things simple and we can do them complicated. All right. Financial functions also have been around a long time. Calculation of interest rates, payments, analyzing loans. So there's a whole set of functions. So if somebody asks you to, what should be the monthly rate? What should be the monthly payment for a loan of X amount of dollars, over X number of, over X period of time? You could calculate that by hand, or you could just simply call the PV function and give it that information, and it will return that. It will calculate it and return the results. So when we talk about logical functions, so the logical functions are a key part of computers and systems. So it's really how we make decisions. How do we direct the flow of the processing instructions in a computer? Right? So there's three things. There's three core structures in a computer. So there's sequence, which is you execute one instruction or one command after the other. Another one would be iteration, where we do a loop. Do this set of commands like 1,000 times or 1,000,000 times. Right. And the third one is decision or selection. All right. So you're looking at evaluating some condition. Is A greater than B? Is A less than B? Is A equal to B? And based upon that, choosing a path, either going one direction or going another. So the idea is it's a decision point. All right, so we see some of the core logical tests, less than, greater than, equal to. Something to remember, because this is always, something people will forget, is that equal to is not the or less than is not the same thing as less than or equal to. All right. So the set of numbers that you have with numbers that are greater than 100 start with 101 versus numbers that are greater than or equal to 100, which starts at 100. All right. And it doesn't take much to computers are not that they're not necessarily smart. They're very precise about things. So you have to be very direct about how you phrase the question. All right. So if you want to say, give me everything that's equal to, or greater than a number, you'll get a different result if you ask, that versus something of just being something greater than. All right. So there are functions inside of Excel, logical functions that deal with this. So there's an if function, which will we put a value. What we will do is we'll put two. We will return one of two values based upon the result of the test. We look at it. If it's this, if A, if it's condition A, return B, or return A. Otherwise return B. All right. So value if true, value if false. All right. So it's a binary decision. So we can do, one of the things within functions, actually, as you get more complicated functions, because you can stack things up. You can have multiple functions, calling functions, multiple tiers of things. And, you think of a function. Function is actually computer code. It's actually a program that has been pre-written that we're invoking. All right. So, if you stack two or three of these things together, what can happen is you'll have a situation where, if something goes wrong, if you have a problem, you get an error, going back and try to figure out what that error is. So there's functions inside of, if you double click the cell, or if you double click on a cell, it will return the edit mode of the cell, which will show you what the formula that's in that cell looks like. All right, which is what they call edit mode. You can do the same thing with F2. All right. And then you can also do on the formula, on the ribbon, if you click on the ribbon, you'll actually will see there's actually a tracing option. So if you invoke that tracing, it will tell you, it will step you through kind of the execution of that formula, with those functions. It will hope you to enable you to kind of pinpoint where the problem is at, especially if you've got something that's stacked like maybe 3 or 4 levels of functions, one calling the other, and you get an error coming back. It's like, okay, where do you start? All right, so there's functions within Excel that lets us check on that. All right. One of the other things, and this is kind of as a streamlining approach inside of Excel. One of the things that Excel has done, one of the things they've worked on, is adding, combining selections of data, being able to do selections of data and logical functions. All right, so the idea is we can do an average. We can calculate like the count of how many items are in a row or a column or a selection of data. And then, based upon what those results are, we can have it do a decision. So the idea is one way to do it would be, okay, you first would execute a statistical function. So you say you can calculate the average, and then do an if on the average. Do an if on the average, or you could use what we call the count if. The average if, or they call or if or IFS. So the difference between an IF and IFS is that an if will be a single criteria. It will just check on one thing, whereas an IFS will do multiples. Is it greater than 5? Is it less than 22? Is it like for ranges and things like that? All right. So really, what it is, it's a combination of both the the statistical functions along with the logical functions, the if statements. And we do similar things with math functions, kind of this combination, conditional math functions. So a sum if, we sum up a range of numbers, we take the result, and then based upon that result, we evaluate it against an if statement, and pick a criteria or pick some sort of direction. All right. So what we talked about in 3. So 3 is about a couple different areas around cell references, about cell addressing, how we do addressing, how we can do by default relative addressing, absolute addressing, where we lock a cell to a location. Relative cell references will, when we copy those formulas, will adjust itself automatically. All right. If we don't want to adjust the cell references, we can make them absolute by putting dollar signs on them. Right? And we can do either the cell. We can either do the column address, or we can do the row address, or combinations thereof. All right, or both. All right, so we can have, if we do both, it locks to a particular cell location. Or we can do mixed cell references. We combine, rows, columns. We lock the row and pivot on the column, or vice versa. Talk about name ranges. The ability to create, take a selection of cells and give it a name, and then use that name in a formula. All right, so we have the ability to, so it's really the ability to kind of create a structure, a usable structure, which streamlines, instead of having to go back and work with everything as as name ranges, or as cell ranges. We can create a shortcut name and be able to use that shortcut name. Functions, we kind of introduced it into, but we went back and looked at it a little bit more. Arguments of a function. Remember, every function will have a set of arguments. So a function, the way you invoke a function is we do an equal sign, because it gets treated as a formula. We put the function name followed by a parentheses, and then within those parentheses we will put whatever arguments we need for that particular function. All right. Every function has its own structure of parameters it will take and what it requires. So if you're going to use it, you probably need to go back and take a look at what the parameter listing, parameter structure would be. There are functions for a whole range of them. So math and statistical, date, time, text, lookup, financial. There's a specific set of functions around logic, which actually drives logic, where you can compare two items, two cells, two values, and then or check a condition, and then choose a path. All right, so this is like the if statements: if this, if that. Troubleshooting functions, we can do a trace, especially because we can combine multiple functions, strings of functions together. And as things get more sophisticated, if something happens like maybe 2 or 3 levels down, you want to be able to run a trace to kind of trace through and see where it's breaking. All right. And we talked about conditional aggregates, where we've combined. What we do is we combined things like the mathematical, or the calculation functions with logical functions. So in fact, what it will be is like a count if will be take a range of numbers, count them, provide a count of what's in there, and then and then do something based upon what that result would be. And we can do a similar thing with math functions. So I can do a sum of a range of numbers, and then do a sum if, which will then make a decision predicated upon what those results are. All right. And that is it for Chapter 3.